So capacitors in parallel. See, if I are connecting one after the other, the capacitors are connected in this way, one after the other. See, this is a cell. Okay. See, cell is not the same. Cell is not equal to a battery. What is the purpose of a cell? Cell is used to provide. It is to provide potential difference. It is to provide PD, potential difference. Okay. And what is a capacitor? Capacitor is used to store energy. Capacitor, it is used to store. It's a component to store. It is a component. It is a component to store electrical energy. Electrical energy in the form of electricity. Okay, in the form of electric field. So, if you look at this capacitor, this is a cell. Okay, let this be C1, C2, C3. Charge here is Q1, Q2. Charge here is divided Q1, Q2, Q3. But potential is same. Potential difference, yes. Potential difference is same with all the values. Okay. Now, Mr. Yashwan, I told you if you are not interested, leave the class. Come here, sit here. No? What happened? Not able to see. Now here, capacitors is what here. Charge is see here. Here the charge is Q. Charge is Q1, Q2, and Q3. So we are adding up charges. Q is equal to Q1 plus Q2 plus Q3. Now we have the formula Cp is equal to C is equal to Q by B. Okay. C1 is equal to Q1 by B. C2 is equal to Q2 by B. And C3 is equal to Q3 by B. Now what is the formula here? We have to add Q is equal to Cp into V. So Q1 is equal to C1V, Q2 is equal to C2V, Q3 is equal to C3V. Okay. Then substitute the values. Okay. Substitute the above in equation 1. So what is the formula now? CPV is equal to what? C1V plus C2V plus C3V. So Cp into V is equal to V if you take common C1 plus C2 plus C3. V and V will get cancelled. So we are left with what? Cp is equal to C1 plus C2 plus C3. Okay. So this is the formula. Now, see once again I will explain. See here the capacitors connected one after the other, or one above the other. So that means all the positive are connected to one terminal and all the negative are connected to the other terminal. Then the capacitors are said to be parallel, and it is connected to a cell. Keep that in the mind. A cell it is only to provide potential difference, and this is to store electrical energy in the form of electric field. Understood? This is the difference between a cell and a capacitor. Don't think both are same. Now, here the charge is Q, that is divided into Q1, Q2 and Q3. So Q is equal to Q1 plus Q2 plus Q3. This is the capacitance formula. The effective capacitance we are writing Cp. Cp is equal to Q by V. C1 is equal to Q1 by V. C2 is equal to Q2 by V. And C3 is equal to Q3 by V. Now cross multiply this, all this, we'll get this. Substitute all these equations in one, we'll get this. Take V common, you'll get cancel the V, you'll get this form. Now if there are n number of capacitors, for n number of capacitors in parallel, we have, what is the formula? So Cn is equal to Cp is equal to what? C1 plus C2 plus C3 dash 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 Cn. Okay. If if C1 equal to C2 equal to dash dash dash, Cn equal to C, then what will happen? Cp will be equal to n times of C. This is the formula. Is that clear? Cn Cp is equal to n times of C. Is it clear all of you? Yeah. So this is about the parallel combination. Now the last derivation is energy stored in a capacitor. Okay, for Saturday class, Saturday I am again in the examination duty. I will be recording a class tomorrow, Friday. Because last Friday I was not free. I was again in examination duty. But now tomorrow I will be recording class with the numericals. And I will send you the link. Okay. So please click that link and we can go through the listen to this.
You will send link on Friday or Saturday?
Saturday morning. So 1 hour class. What do you need? To the link in class group is there, right? Yeah. Okay. Okay. Yeah. So all the best, so congratulations to all of you, all the people. Did you get anything? Huh?
I got lead with the O.
Why he is upset? What is the problem?
Sir, he didn't
get anything.
Yes, sir.
Did you apply? Did he apply anything? Did he apply? For what?
Ruby also.
let me just stop this recording first. Then I can talk. The next one is energy stored in a capacitor. So no, see here.
So the derivation is deleted.
Yeah, I should know.
No, derivation is deleted.
I check.
What will I show you
Yes. After I say now recording the class, please don't
deleted.
So energy is there. Only anti-graph generator is deleted. Anti-graph generator is deleted. Last one is deleted. Energy is there. Energy, there are two derivations. I will tell you. Why? What is deleted exactly? In energy, we can solve energy by using integration method. That is deleted. But the other one is not deleted. There are two methods of solving this one. Integration method is deleted. Not the other. Same formula. But energy is there in the syllabus. Don't think it is deleted. Okay. So read that carefully. The terms. Now, so now see here. This is a positive plate and yes, please. Positive plate and negative plate. So this is the electric field. Okay, this is the electric field. Okay, positive charge plus and minus V. And this is the electric field. Is that clear? Now, what I am doing here is yes, please. Now, this is the electric field here. Now I am transporting. Yes, please. Stop talking. I am taking a small charge. I am taking a small unit positive. Now there is a delta Q. See, I am taking a delta Q charge from positive, from this positive to negative. I am moving this charge from negative plate to positive plate. There is a small, see, negative plate means what? More number of electrons. And positive plate means less number of electrons. Less number of electrons, not protons. Less number of electrons. More number of electrons. So we are transporting a positive charge from negative plate to positive plate. How much work we are doing? Okay. How much work we are doing in transporting this charge from here to here? So we have a formula here. W is equal to work done. See, we have the formula V is equal to W by Q, which we studied in the second chapter. Okay. And W is equal to what? W is equal to VQ. Now, suppose if you have delta W, we write that is what? V into delta Q. If you want to find out the if you want to find out the entire value, you want to find out the entire value for entire or for whole value, whole charge. Okay, so we are writing here W is equal to integral V dq. Okay, integral V dq. Is that clear? Yes. No, here we are not using the entire. Here it is completely full integration. We are only using here in the first term. After that, we will not use.
V is constant.
Here, V is equal to what? V C. We have the formula. C is equal to Q by V. V is equal to what? V is equal to Q by C. Okay. We are going to substitute this in 1. Okay, this is 2. Substitute Substitute 2 in 1.
Sir,
Yes, please.
No, sir. Yashwant asked why we are
No.
substituting.
Yeah, we are substituting to find out the energy. Okay. Now integration of q by c into dq. Okay. Now what is that here? 1 by c is constant. Please take it outside. Okay. Now integration q dq. Now see here we have integration of x power n dx is what? X power n plus 1 by n plus 1 plus c. Okay, this is the formula. Integration x dx is x square by 2 plus c. Okay. So these are the two formulas. Okay. Now w is equal to what? W is equal to 1 by c. Here it is q square by 2. It is q square by 2. Understood now? This value is q square by 2. So it will become what? W is equal to q square by 2c. Or we write energy is equal to E is equal to q square by 2c.
Sir, no limits.
No. Okay. Now q square, that is enough. Only for the entire we are taking. Okay. Now you take 0 to q. That's it.
Okay.
It will be same. No, that's what I wrote here for entire. So I don't want to write
Fine for a small amount of charge.
0 to q I am writing. So it will be same. That's what I mentioned for entire or whole charge. Now, so q is this is the third equation. So you know c is equal to q by v implies q is equal to cv. Substitute this here. W is equal to what? C square v square by 2c. So c and c will go away. Answer is 1 by what you got? 1 by 2 cv square. This is the fourth one. One more way. So w is again c is equal to q by v. Okay. Q by v into b square by 2. This and this will go away. 1 by 2 into 2. So what are the three formulas now? So from 3, 4, 5. From 3, 4, 5 we have energy E is equal to what? That is q square by 2c, which is equal to 1 by 2 cv square, which is equal to 1 by 2 q into c. These are the three formulas for energy stored in a capacitor. Okay. Derivation don't learn, no problem, but learn the formulas. Is that clear?
For energy stored in the capacitor.
Energy stored you have to learn because it is only very few steps. See, this is only conversions. This is only conversions.
The other one is very big.
Only this one. The other method of textbook is difficult. So that they have deleted. Okay. Is that clear? This only is there. The other one is summation is there. That is deleted. Okay. So only one is there. There are two ways in which we can find out this. Is that clear? Okay. So please copy this once again. See here. We have positive plate and negative plate. Electric field is going from positive to negative. We have formula V is equal to W by V, W equal to V. Work done and energy are having the same dimensions. Both are measured in joules. Now, delta for small work done, we have V delta Q. For entire whole charge, we write integration. And also that is continuous. Now, C is equal to Q by V, V is equal to Q by C. Substitute this equation 2 in this equation, then we'll get this. Take 1 by C constant outside. Q is a variable. Q is a variable with respect to dq. Now we have W is equal to 1 by C Q square by 2. So derivation of x is x square by 2. We are applying here. We got this. Now substitute this C value here. Just it is modification. It's only substitution to get three different formulas. So we got these are the three formulas for energy stored in a capacitor. Now last one is energy density. Energy, what is energy density? Energy density means, see, energy is measured like we write U here. In the textbook is using letter U. Energy density is small u. Small u is equal to capital U by B. Means energy density means energy stored. Yes, please. Energy stored per unit volume. Energy stored per unit volume. That is said to be energy density. So U is equal to what? Capital U by B. Capital U by what is B? B is equal to A into D. Volume means area into distance. Okay. Volume means C. Here between the two plates, there is a plate area. This is a plate area. Area is A, distance is D. So this whole thing becomes a volume. This whole thing will become a volume like this. It's becoming like a volume. Is that clear? It becomes a volume now. So that is where we are writing A into D. Is that clear all of you? Is that clear? Now what we can do is I will take one formula out of this. What is U? Half CV square I will take. Example, half CV square divided by A into D. But what is C? C is epsilon naught A by D. Epsilon naught A by D. And D square and A here and D here. Okay. So A and A will go away. What is the formula now? That is 1 by 2 epsilon 0 D square by D square. Is that clear? C is equal to epsilon naught A by D. Okay. So this is the formula for energy density. Small u. Is that clear? Small u is how much energy stored in unit volume. Is that clear of you?
Yes, sir.
What happened? Energy per unit volume. Volume is area into distance. Okay, just substitute the value and solve it. You get the paragraph. So this completes your lesson. Okay.
Yay!
One by CS equal to 1 by C1 plus 1 by C2. So 1 by C2 plus 1 by C2. Okay. And CP is equal to C1 plus C2 plus C3. Sixth one, U energy is equal to U square by 2C equal to half CB square equal to half Q into V. Okay. Now seventh one, last one, energy density U is equal to what? 1 by 2 epsilon 0 V square by D. This is the formula for. Okay, this is the formula. These are the 7 different formulas for capacitance. Potential already have given. Okay. Is that clear of you?
Yes, sir.
Yes, Mr. Arjun. Some clear? What happened to you suddenly? Huh?
You didn't just let go.
No. No.
And sir, that energy density zone.
Okay. Now can I solve a numerical now quickly before textbook beginning? Is anyone having textbook with you? Now, see, you have to all of you have to do the example questions in your copy the example questions in your notebook. All of you. All of you have to copy the answers of the example questions in your notebook. This is for the practice purpose. Example questions, okay? And exercise also you have to solve. Is that clear? Both exercise questions and example questions copy to your notebook. Is that clear? Don't write the question, not a problem. Write at least the answer. Write the page number. See how will you write example? Suppose this is question number is 3. Question number is page number is suppose 24. Question number is maybe 30. Like this, write this. Finish. Don't write the question because anyways you have the textbook with you. All of you have the textbook, right? So just write the page number, question number, and write the answer. I am not concerned with the question. Is that clear? Write at least the answer. Is that clear? Now I am going with the yes, sir. Yes, sir. Please. Just 2 minutes. 2 minutes. We will guide check. Just 2 minutes. Yes, sir. Now there are 3 capacitors. I will send this. Anyways, it is recording. I will send this to HM directly.
No, okay. Check.
There are 3 capacitors. Okay, there are 3 capacitors. 3 capacitors. Exercise question. There are 3 capacitors. C1 equal to C2 equal to C3. 9 picofarad. What is the total capacitance? Series. 3. Can you calculate this time? Can you please? Can you please? Yeah, please leave.
You leave. When do you leave? Disturbing the class.
Can you please calculate the effective capacitance in series? Yes, quick. 1 by CS is equal to what? 1 by CS. 1 by CS is equal to 1 by C1 plus 1 by C2 plus 1 by C2. So 1 by CS is and all are equal, right? So this is equal to C.
3 by 9.
So 3 by C. So it will become CS is equal to C by 3. What is C value? 9. 9 picofarad by 3. That will become 3 picofarad. So that answer will be 3 into 10 to the power of minus 12 farads. Please note down the answer for this. 3 picofarads. Next question. There are 3 capacitors connected in parallel. 2.7.
Stop banging your bags first.
See here, C is equal to for parallel. CP is equal to C1 plus C2 plus C3. So CP is equal to what? 2 plus 3 plus 4 picofarad. Okay. So that will become how much? CP will be equal to 9 picofarad, which is equal to 9 into 10 to the power of minus 12. Thank you so much.
Sir, finish recording.